sum and difference of powers. So what am I talking about? Factorising this sort of expression. So we've talked about this before back when we did algebra, but it's timely now to look at it again. So you've got something like a to the power of n minus b to the power of n. Remember, it can always be factorised, taking out a minus b as a factor, and then in the second parentheses, starting with the power of a, and the powers are going down by 1, the powers of b are going up by 1, but the two powers always add up to be n minus 1. Until you get all the way to the end, b to the power of n minus 1. Now that works beautifully for minus. When we have plus, similar sort of pattern. In the first parentheses we have a plus b, so it matches basically the type that you're factorising. But in the second one, now the terms alternate between positive, negative, positive, negative, positive, negative, and so on. But this one only works if n is odd. The reason why, and let me explain it with a cubed plus b cubed, because what you're technically doing is you are actually using the first formula. But instead of looking at it and saying it's the sum of two cubes, you're saying, oh, it's the difference of two cubes. The second term is negative b all cubed. Now you can do that when the power's odd, but you can't do that when the power's even. So really I'm saying it's a minus b, and that's why I get the a plus b, and also explains why the terms alternate, because every second one's going to have an even power, so the negative becomes positive. Then the odd ones, the power becomes, the term becomes negative. So that's where it comes from basically. So it only works for odd, but the negative one will work for all powers. So there's our example. If we had minus 32, I know, well, it's x to the power of 5 minus 2 to the power of 5. X minus 2 comes out. Powers of x will start at 4, go down by 1. The powers of 2 will start at 0, so 2 to the power of 0 is 1, and then go up by 1, and there's our factorisation. Later in polynomials we'll see that actually it should be possible to factorise this second one, because every polynomial can be factorised down to be a combination of quadratics and linear functions. So anytime you've got a factor that's bigger than a quadratic, it should be able to be factorised somehow. Now, it might be through the use of complex numbers, which we'll see later, but theoretically it should be possible. Alright, so we'll just add a handful of those questions to our work.